Well, hi, good morning. Thanks so much for joining me here in my shop on a very, very cold February 14th. Temperature outside is minus 22. It was minus 23 when I got up this morning. So it's warmed up. It's warmed up outside. Very cold. So, nice to be in the shop here. So what I want to do with this radio and amplifier today is focus on the audio circuits and look them over and see if there's something I should do. Typically I'd be replacing capacitors, but maybe not in this case. When I look in there and I see all these paper capacitors, and then I notice 1, 2, 3 molded capacitors, and they all happen to be in the audio circuits of the radio. So that's kind of curious. Did somebody change those some time ago? Now I looked at the soldering and the way they're connected, and the impression I have is that they're original, but I have a hard time believing that very much. These are all 0.01, despite the fact this one's yellow and this one's red. I don't know why that is, but it is the case. They're all 0.01, and on the schematic they should all be 0.01. This one is conveying the audio from the wiper of the volume control to the grid of the preamp tube, or the detector tube, the audio amp portion of that tube. This one, Hello?
Hi there, may I speak with Jim, please?
This is Jim speaking. Okay, I'll be picking up some groceries a little later this morning, so getting back to what we're doing here. Right, so this last one is tied between the cathode and the plate of the output tube. Typically there's a capacitor there. I think it's there to drain out any RF that's still making it this far in the radio. I'm not really sure what this capacitor is for, but it's in all radios. So the question is, are these good or are these bad? Should I bother changing them? They sure look fine to me. The looks can be deceiving. So there is one here I can test in circuit, and that's this one. It's connected to the grid of the output tube and to nothing else. So basically it's connected to nothing at this end, especially with the radio switched off. So I'm going to test this guy and we'll see what we get. I'm going to make a judgment about the others that way, because I suspect these are good. But suspecting and knowing are two different things. So it says 0.015 microfarads. 0.015. It's supposed to be 0.01. Loss is 5%. So the higher measurement, instead of saying 0.01, it's 0.015 or 0.016 actually, suggests the capacitor is leaky. You know what? I can test this with another tester. There's no reason why I can't. I'll put the leak tester on it. We'll see what happens. I'll get that set up here. Okay, let's switch it on, let it warm up a bit. So the way this tester works, it does two different things. One is it will measure the capacitance. It uses a bridge circuit inside, has a standard or known capacitance inside it to compare. So you do the measurement by turning this knob. You can see different things happening here, but that's just nonsense. The eye here is the output, or the thing we look at to see how things are going. The other test, boy, that was helpful. The other test that the unit does is it will apply a voltage, select the voltage here, and that voltage will be impressed across the capacitor. Some amount of current will leak through the capacitor. In a new, good capacitor, that leak is so small it has no effect on the eye. Now, what effect am I talking about? If there is a current flow, the eye will close. So when I go to do the test, there will be a current flow initially as the capacitor charges. So during that time the eye will close, and then as the capacitor fills up and the charge rate slows down, the eye will open. If it opens all the way back to here, then there's really no leak in the capacitor. A bad capacitor on 50 volts, I know it says 25, but it's actually 50 volts, will close this thing and never open it. Here we go. Did I say close it and never open it? So it's not opening. So this is an important thing. We're going to do another experiment here with this radio before I go and change it, but for sure it needs to be changed. You can't leave that one in there. This one in particular, the one I just tested, is the blocking capacitor. Maybe I'll put it on the schematic here. We'll take a look at it too, what it's doing. It's the blocking capacitor for the grid. That's one of the reasons why you might find this particular capacitor changed in a radio like this when others haven't been. Because early on, somebody, repair guy, recognized that this critical capacitor was leaking. So when it leaks, there's a large positive voltage here. Some of that will leak through, or some of the positive voltage will leak through. That's a really bad way of saying it, but there'll be a positive voltage will develop on the grid. That's really bad for the output tube. You want a negative voltage, or I believe this one has a cathode resistor arrangement with it. So it would be, the grid would be negative with respect to the cathode, but not if it's leaking. It could go positive, and then the tube will work way too hard, and eventually you're going to wear out the cathode in the tube. Now the tube that was in there was worn out. Here it is here. It was worn out. Did it wear out because of the high grid voltage? We don't know, but I'm going to make some tests here. We're going to find out. So we need to identify the cathode on this tube. And the cathode is, looking here, 50C5. The cathode is pin 1. So cathode on 1, grid on 2. 1 and 2. So 1. So this would be the cathode resistor. This little guy here. Brown, green, brown. So that'd be 150 ohms. I'm just going to peek at the schematic here myself. And 150 ohms it is. So this is the cathode resistor. Usually these are larger wattage resistors than this one. So this is what's providing the bias by pushing the cathode more positive. That makes the cathode positive to the grid, or the grid negative to the cathode, which is what you want, unless this guy's leaking. So we're going to measure between the cathode and the grid. We're going to do that with a isolated meter, not one of my, not the VTVM. That would present some problems doing the test. And I am going to set this up. Yeah, we can just use the leads on this. So we need this operating. We don't really need, need it to be playing any music or anything like that, because these are DC voltages. They're not really the signal. Just hooking up the speaker, because you do not really want to operate one of these radios without a speaker connected. Okay, a little practice session. We would expect the bias, I think it was written on the schematic, if I remember right, it was 6.2 volts. So we are expecting 6.2 volts with the cathode positive to the grid. We should be able to do this. We should see a positive 6.2 volts on the meter there. I think we're ready. Just put this out of the way. And we need to plug it back in. Okay, switch it on. Keep the volume low. So what we're trying to answer here is the question, you missed it, but my lights came on and went down again. Is the bias appropriate on this tube? Or is this capacitor leaking so badly that the bias is off? Put this up on full. Radio's operating. Positive on the cathode, negative on the grid. Positive on the cathode, negative on the grid. So we're getting positive 8.7 volts, which actually means that there is a proper bias there, a little high in fact, 8.7 instead of the 6.2. So that suggests there's no leak through here of any significance, yet my test indicated there was. What do you do about that? Conflicting information here. A big decision whether to change this or not. Wow, so the test I did with the 50 volts showed a bad leak. Just one sec here. Yeah, my machine was set correctly. Let's check that again. Am I doing this right? Should get a positive voltage. So a little higher voltage is not so bad in the sense that the tube will run even easier than intended, have less what's called quiescent current, or just the current that's flowing through the tube when there's no signal, no sound. If we look in here, these books usually give recommended amounts and stuff like that. Grid number 1, control grid voltage, minus 7.5. So they're recommending not the 6.2, but the 7.5. And it only gives one. Here's a whole chart. We could study away on this, but I'm not going to. If the bias is too high or too low, another problem can happen, in that there's a linear operating range for every tube, and you want to operate them within this linear range. So two tubes have a characteristic curve of some sort, but there's a linear area here in the middle, and you're trying to shoot the bias into the middle of that area. So if you let it go a little high or a little low, then you'll start operating the tube outside of the linear area. That's going to lead to some harmonic distortion. A little bit is easy on our ears, but a lot is not. Then, the last way to check this is to try to measure the actual cathode current or plate current. I don't normally do that stuff because, man, it's difficult to make a measurement. Wow, okay, conflicting information. Doctor, what do you do when you have tests that don't jive? You admit that you're not sure and try to come up with another test for your patient. Do not just guess at one or the other. Or you just go ahead and do the surgery. And yeah, there's a risk with all surgery though. Can I test another one of these capacitors? Now the other two are in circuits where there's influences on it. This guy's connected into the volume control, the other side's got a resistor going to what looks like a B- terminal. This guy's connected across two tube terminals, but at the same time that's like being connected. Let me look at that one. I'm looking at it right here, in fact. So that one, I can test that one. I can test that one. One more time. I can test that one. So this one with the set off, turn it off, is also connected to nothing. So I should be able to do the test on it. Okay. I have to to give this a little bit of time here for voltages to drain out. Is there anything on it? Oop. Just checking to see if there's anything left there. Teeny tiny amount. That's an interesting reading on this capacitor. Where's 1 volt come from? This is going to a grid, which is open. So it's just like I cut this lead and this capacitor is just sitting here going nowhere. Just because it's hooked up to this terminal doesn't mean anything. It's going nowhere. Yet somehow I can read an increasing voltage across it. How does that happen? It is possible for old capacitors to become little batteries. Terrible, terrible little batteries. You're not going to power anything from it, but you can power a meter like this from it. Is that what I'm seeing there? That's a huge voltage, 1.7. Pull that tube out if it's not too hot. Whew, it's a little warm still. In my mind, this tube can't influence this test, but that's in my mind. Here we go. Disappeared. Well, isn't this a curious thing? I tried to say that the tube was still hot enough that there were electrons doing stuff inside it. The tube always hot enough? I mean, even room temperature? There is some emission at room temperature. You'd have to think. It can't be much of anything, can it? Can it? I love these curious things. Look at that now. What's the grid voltage to just the ground for whatever reason? 0. And the other side, voltage is over here. Still is kind of weird. You can read it. How could you possibly read it? So if this has a bit of resistance in it, it's more like a very high resistor going nowhere. Why would I still see this voltage? Pin 2. That's the grid. That's really mysterious to me. That's really, really mysterious. I love these kinds of things. This makes my day. You get something that just doesn't make sense. It means there's this hole in my understanding of things here, for sure. Well, we can ask the next question. How come there's a voltage here? I'm asking that question. So this could be voltage coming out of the any capacitor, really. But all these ones would discharge really quick. And the only really big guys in here are the filter capacitors. Here they are here. It's this guy here has 3 capacitors in it. Fairly large ones. So I'll only look right on those. This is, unplug this. Unplug it. Does that make any difference? It shouldn't make any difference. But at this point, goodness knows what's going on. It's getting more and more. It's going up. Okay, so we'll ground one lead, and we'll just look on these capacitor terminals. So there's 3 volts hanging on in there. 3 volts hanging there. Nothing. So what I'm going to do, I'm going to put a short on here. A shorted to the B minus. So I'm basically shorting out the power supply here. Take a long time for a capacitor to discharge, much longer than people might think, especially electrolytic. It can take a long time to fully discharge. Now, let's check and see. This looks stupid, but let's check and see what's happening here. Should be a 0. Good. So even if there is a bit of charge left in here, it's going nowhere. Did that get rid of this weird effect? It did. Okay, so somehow through some machination, the voltage that's residing in here is appearing here to this open terminal. It still doesn't really add up, but I think that's as far as I'll pursue that for now. Back to whether to change those capacitors. You know, it's not a difficult thing to do. So I got a reading with this guy here. Let's just repeat this. There's always a cost to education. Sometimes we pay it this way, just by spending time doing stuff like this. Okay, now it's reading higher. It's 0.02. 6% loss. 6% loss. Now let's just keep honest here. I'll grab a nice 0.01 capacitor. This is a lower voltage one. Now this one is essentially brand new. See, the loss is 0, and this is showing whoa, picofarads. 0.01. That would be 0.009 or 0.01, which is what it is. But you see the loss? 0. 0. Well, I'm going to go drink some coffee and just think about this a little more. Okay, well, I'm pretty sure I'm on my way to changing these, but one step at a time. So I disconnected one lead here, and we're going to repeat the leak test on it. After getting the strange tube in, tube out findings. Okay, let's go take a look. What happens this time? The last test really indicated the capacitor was bad because the eye didn't open at all. Here we go. How do you like that? Okay, now it's testing just fine. Let's give it a little more voltage. It's testing like new. Leads are connected. Yes, they are. If the leads weren't connected, the eye doesn't close because the charge up time is instantaneous, so it just stays like that. So it's charging the capacitor, and the eye's opening all the way. The tube is leaky? Oh, I don't get it. I still don't get this. So I'm going to attach the other end to the grid. I'm going to put 50 volts on it. Grid to, well, let's start with this terminal. I'm not even sure what I'm doing there, but we'll start with that terminal. We'll move it to the ground in a moment. This is crazy, but here we go. Look at that. I'm going to pull the tube out and repeat. What's going on? How does this happen? Did I stick a wrong tube in there? 50C5. there's a leak between tube elements, but I did the shorts test on the tube tester and it didn't indicate anything. This is really weird. So in my mind, just to be really clear, this terminal, the grid terminal, ties to a grid which is just a piece of metal floating inside this glass jar. It happens to be close to other things. The test is being done with DC, so there can't be any capacitive effect. There. I don't know, this is really quite weird. Let's put that there, and then the cathode is right on number 1. So I'll try and put this on the cathode if I can, without having a short. Never done anything like this. You know, if you look where you don't normally look, then you see what you don't normally see. And maybe you're better off not seeing it. This is just crazy stuff. Okay, I think that's fine. I don't think they're in contact. Wow, it's close though. Okay, no contact there. You know, what else would I expect? Is there something going on with the socket? No, I pull the tube out, the thing goes away. It must be to another grid. So the next grid in line would be the. I have no idea what I'm doing here. This is not at all what I thought I'd be doing this morning. The next grid would be pin number 6, which is the screen grid. So I'm picturing the control grid sitting between the cathode and the screen grid. And so if it's going to touch or leak to something, yeah. Well, did this fall off during that test? Or did I take it off? Maybe it fell off. Let me just repeat over here, or repeat. No, it looked exactly the same. Oh, it fell off again. Okay. Stay on there, don't short. That's really close, but I think it's okay. Here we go again. Yeah, look at that. Just pops wide open. I'm not sure if you're seeing that clearly in the camera or not, but okay, so if we wanted to try the grid to the screen was 6. 2, 3, 4, 5, 6. Don't really care if it shorts to other pins. It just makes the test even more valid, I think. Kind of think. How valid can this really be? What is happening? What is happening? Something going on. Now look at this. Look at that tube socket. Can you see it's darkened in the middle? If you look at the other tube sockets, and it's a little hard to do, they seem to be a very consistent, nice brown color. This one is darkened in the middle, and if you look at this one, the whole thing is darkened. That's because these two tubes run hot. They run hotter than the others. Could it be carbonization inside that socket? This happens. This kind of thing happens. How can we get a hold of that? Why don't we just take the tube is out. We'll take the ohmmeter here. The grid has absolutely nothing connected to it now. Okay, so I'm on 20 megohms here. And we're going to go from this grid. Well, let's go to the ground. Nothing. Let me just check this again. Yeah. Okay. Now let's go to this center ring here. Nothing. Go to these other terminals. What I'm thinking is there's a carbonized conductive path inside this tube. It certainly isn't showing up at all, is it? Okay, let's put the tube back in. I just don't have any idea what it is I'm chasing here. Repeat those tests. So to ground. $500,000 ohms. I don't know what to make of it. I don't know what to make of this. So 500,000. Pull the tube out. Nothing. How do you get another tube? Put the tube back in. Just any tube, really. No, not any tube, because we still want the grid to be on. We want the same. We want the same. 500 again. Is there something about this tube I'm not getting? What could be different about it? 50C5. Sometimes a grid has two. Yes, yeah, there's two ways in. Oh. Oh, okay. There's the answer. There's two terminals for grid 1. Duh. So we gotta look over at this other terminal and see what's on it. We'll probably find stuff on it. This is probably all it is. It's probably all that it is. 1, 2, 3, 4. Did I say 5? And there it is. And look at that. It's a 500,000 resistor. And where's it going? It's going to the can of this. Now, notice this is cardboard covered. And you look inside. It's a little hard to see, but it's not metal to metal. There's a non-conductive brown plate down there, keeping it out of contact. A little hard. No, it's not so hard to see. It's hard for me to tip the camera. You can see there's the brown plate riveted to the chassis. So the whole capacitor is isolated away from the chassis. And that's because everything is isolated from the chassis in this radio. So how's that deal? How's that work out? Well, so right from the start, when I thought I was testing this capacitor to a grid only, it was not. It was going. So that's why I saw a leak on it. That's why I got the weird reading on this. Let me just repeat this now. Because it wasn't isolated, because I missed the facts here. Oh, look at that. Oh, still has a high, oh, still the same readings. So that's a 0.017 microfarad, 4% loss. And when I did the, I gotta repeat these things. The high voltage test, there was no leak. Okay, here we go again. 50 volts, no leak. 250, yeah, no leak. It's perfectly good. It's perfectly good. Okay. What kind of a weird journey. So I'm going to solder that back in. We're going to assume all these are in the same condition. That's a good assumption. There's no reason to think they aren't. The amount of leak through here is minimal, if anything at all. I mean, there's got to be a few electrons making its way through, something like that, but not enough to cause a charge to build anywhere, and we saw the bias itself. We measured it. It's okay. High, if anything. High negative, if anything. Okay. Okay. Camera's not steady. There we go. Look it back up. Hey, we're done. Kind of a goose chase there, right? A wild goose chase. There are wild geese around here. So we had to throw that fish back in the water. Let's see if we can find another fish here. So thinking about the phono input here, and we looked at it yesterday, looked at it on the schematic. Cable comes along, comes over, ties into the switch. The shield of this part of the cable comes across on a black wire to this terminal. And then there's this capacitor, which is connected to a B- point. So this guy, if it were shorted right out, this would be a dangerous radio to plug something in to the phone. It'd be quite dangerous in terms of getting a shock. Depends which way you've got it plugged in the wall for now. But again, not here in my shop because I'm using an isolation transformer, so that issue doesn't exist here. But take it, plug it into any regular outlet with an unpolarized plug. This guy's shorted. This thing could be alive at 120 volts. Wouldn't that be exciting? You take your iPhone, plug it in there. There could be smoke coming out of your iPhone shortly after that. I don't know if that's the case, but so is this guy good? Well, I'm going to test it. I'm going to test it in situ here, which I'm really not at all sure this is a valid test. Let's see what it says anyway. If it says what I like, I'll accept it. 35 nanofarads, so that's 0.035 microfarads, and it's supposed to be 0.027. So it's reading a little high. It's got a V loss number there, but again, is that because of what I'm doing? Pretty sure we're going to change this one out, so I'm going to nip it, and we're going to test it again. I will nip it here. It's just a nice area. We'll test it once again. There's lots of wax on these wires. Yeah, exactly the same. Exactly the same. Suspiciously exactly the same. Okay, let's do the leak test here too, before I cut it out entirely, because I have the extension leads here. Now the only way there can be a leak is through the capacitor, because it's disconnected on one end. Okay, oh great, capacitor checker, leak checker. What do you say? 50 volts. Says he's good. How about 150? Okay, it's having trouble opening at 150. So, you know, this capacitor is not shot entirely, but it's showing its age. If it's in a critical place, like if this capacitor were sitting where this one is down here, trouble would ensue. I'm pretty sure that's enough of a leak there to cause a problem. This is a very sensitive place. The grid blocking capacitors are very, very important. This one, I guess the question would be, does it leak? Could it leak enough to give you a whopper of a shock? Now, you don't need a whopper. Let's say you plug in your nice iPhone. Oh, yeah, you plug in your nice iPhone. I forgot which camera you're looking through. Oh, you didn't see the test because you were looking. Oh, I didn't switch cameras. Shoot. Well. Okay, well you heard what I said anyway about the test, so I'm not going to repeat it. So the question would be, is this going to leak enough to give you enough of a shock that you know it, and you throw your iPhone against the wall or something like that? I don't know how we figure that one out. The only numbers I know is it takes a few milliamps to really hurt you? Could you pass milliamps through here? 120 volts pushing it. I don't know. I'm not about to try to find out. So we're going to change this guy out. Now, he's not the only one. Let me put him back where he is. So what I'm trying to do is clean up the safety sort of side of this radio. So another one would be this one here. So this guy is standing between the B minus and the chassis. It's a big capacitor, big leak. So I'm certain to change this one because we want the safety factor. So I'm going to nip it. I'm going to remember to switch cameras this time. We can't get at it. I've got it so well insulated here. So this is tied to a negative terminal in the filter capacitor. It's a 0.1, I think. Oh no. 0.082. Well, that's almost a 0.1. Maybe they had an excess in their warehouse at the factory and they wanted to use these guys up. I don't know. It's kind of an odd size. Okay, let's give them the test here. Right, switch cameras. We're gonna be careful there. Maybe doing lots of stuff off camera by accident. Sorry if I am. Okay, so this big guy. Bigger capacitors take longer to charge up. Bigger capacitors have a bigger propensity to leak. There's more surface area in them and the like, I would say. Here we go. 50 volts. It's opening. Not quite all the way. And 150 volts. And not opening. So the same question now. Could you draw enough current through this capacitor to give you a jolt off the chassis? And again, who's going to find that out? So that's another one to change. I'm just going to put it here. That would be now is that the only two? I'm trying to remember. Were there only two that were implicated in safety issues? There's another one, and that's the ground here, the ground terminal. You switch cameras. So here's the ground terminal, and here's the ground terminal capacitor. Again, going straight to the negative here. So this one also is a bit of a risk. You're going to hook up a wire up to here, or maybe you're going to hook up a bare wire. Who knows what you're doing. So we're going to nip this one out. This is a 0.027 or 0.03 capacitor. We will return to the capacitor checker. $50 volts. What do you say? Right open. You know, partially open at 150 volts. So it's just like I suspected. The capacitors in this radio are not in the worst condition, and I've done lots of radios where the capacitors are much worse than this. And are they in serviceable shape? The key one here got changed. Why these others were changed too, I don't know offhand. I believe this got changed at some point in the life of this radio. So I will install these three, put 3 replacements in, and the radio will be that much more safe than it is now. I think that's good. Okay, I'm going to do that. I'm going to put those 3 capacitors in. Okay, after lots of distractions, including a trip to the grocery store, I've soldered these guys in. Good, everything's ready to go. We should give the radio a try and see if it works. Now, I didn't do anything that should really affect its performance, as far as I know. Anyway, we're hooked up to the speaker. Okay. Volume's minimal. There we go. Dim bulb's doing the right thing. Offhand, I don't know what band I'm on. I think I'm on the tuning wheel here. Oh, there's that short still there. Okay. Well, radio's working. Lots of volume. Good, that's good. That's all we're going to do today. That's great. Tomorrow we'll start on some of the more radio-oriented capacitors. Well, that's what I think I'm going to do. Who knows what I'm going to do. Thanks a lot for watching. See you tomorrow.